All right, let's get started. This is going to be Circuit 1, Blinking LED from the Tinker Kit Activity Guide. So this is a pretty basic electrical circuit that we create, and this is usually the very first circuit you ever create. We are going to basically program an Arduino board to light up an LED. Okay, so following the guide, the parts that we're going to need, so we need a breadboard, so you see the breadboard here, and we need the SparkFun red board, right? Or if you have the Villarose kit or an Arduino kit or I can't remember, it's like Elegoo kit, something like that, something off of Amazon. But we're just looking for an Arduino Uno type of board, right? So in our case, we're just using the SparkFun kit today. So you need the actual microcontroller, and you need an LED. So it says red. I went ahead with the green one today. Then you need a resistor, right? So this is the resistor, this little guy right here. So 330 ohm resistor, right? So that's the item right there highlighted. This particular resistor in the kit, they come in a bag, and the bag has a label inside of it, so you know what it is. You can also match these colors up to a resistor chart, which we'll talk about in a second, to find the right resistor. Right? But you need 330 resistor, and then you need 2 jumper wires, which are these guys right here. And I do want to point out, right, this one, the picture shows yellow and black, right? I've got green and white. The colors of these jumper wires don't matter at all. All right, they just don't matter. All right, so all the parts are here. The other part that you're going to need, which they don't put on the list, is you're going to need your USB A to USB micro, or if you have a mini. This is a mini, actually. My bad. This is a mini. And then I know some of the Arduinos, I think like the Villarose Arduino actually has like a B. So I think this is a B connector, right? Which is like the kind that you plug into a printer. But you'll need that cable to connect to your computer to make all this happen. On top of that, you're going to need the Arduino Ide. Right, so I'll get that fired up. I'll just put that down here in the corner. Right, so here's our Arduino Ide. So this is our programming interface. Here's all the parts that we're going to need, and then here's our instructions over here on the right hand side. So let's scroll down. If you need the parts, the parts are here. If you bought the kit, you're going to be fine. All the kits have the parts that you need for this particular experiment. If you remember the assignment, I asked you to read the light emitting diode section, read the resistors, read the resistor chart. Those start to explain what these items do, how they function, how they look on a schematic, things like that you're going to need to know going forward, as far as putting together more complex electrical circuits and making things happen. Okay, the more of these things that you read, and the more of them that you start to try to understand, the better off you're going to be, right? So my whole take on learning here is the more time you spend learning about all the components and pieces of whatever it is you're learning about, the better you're going to be, right? And in IT worlds, right, if you want to be one of the the top technicians, the top server engineers, the top network engineers, you need to read a ton, you need to learn a ton, and you need to spend a lot of time doing that. I've spent the last 94 to 2000, so 26 years of my life learning, and constantly learning new things. So I know a lot of students, and I tend to do this when I'm taking classes too, is like we want to get through this thing as fast as possible, so I'm going to go right to the bottom. I'm going to plug everything in, and I'm going to be done. But the more time you spend learning these things before you get to that point, the easier it is to do things going forward, the easier it is to understand what they're asking you to do, the easier it is for you to troubleshoot problems when you run into problems. Okay, so the assignment asks you to read the light emitting diodes, the resistors, the polarity, the Ohm's law, and the electricity, and then several pieces of these so that you have a good basic understanding in the background. Okay, so we're going to play with the digital outputs today. So the digital outputs you can see on this red board here, they're over here. This is a little bit out of focus, but 0 to 13 on this side, those are digital. And then over here where you see the A's, A0 through 5, those are analog. Okay, so we're going to play digital today. And remember, if you've read the material above, that the LED is it has polarity to it, so there's a positive and negative side. You can also, so they show you a picture where there's a flat edge. I don't know if you can see this on that picture there, but I don't have a flat edge on my LED, right? But I do have a long leg and a short leg. Okay, so long legs are going to be your positive side, right? If you see the picture, and then short legs are going to be the negative side. Okay, and then on your resistor here, right? They come kind of built, right? They come with a straight line, so you're going to basically just bend them. You're going to bend them like this, right? So that they go into your breadboard over here. Okay, so the breadboard, that was also part of your early reading, right? This is a way for us to do put these circuits together without having to solder anything together, right? So that would be a whole nother skill we'd have to teach you. We actually used to have a soldering class here at CNM and part of the electronics program, but the electronics program closed down. So here is the diagram for how we're going to build it, and usually I use just a diagram to build these. If you want to be really super precise, you can actually follow the chart down here that'll actually tell you exactly where to put things. For example, right down here where it says resistor, the 330 resistor is on E2 and F2, right? So if I look over at my board here, up here on top, there's an E right there, and that's going to be this column, and there's an F right over here, and that's going to be this column, and then there's a row 2, right? So that's going to be this row. So when it says E2, it is there, and F2 is there. Okay, and you can see from the picture as well, I mean, they have it in the same exact spot. So if you follow this picture, actually they have it in G2, right? It's kind of funny, right? So the picture shows G2 and over here it shows F2. Okay, both of them would work, right? Because remember, everything that's plugging into, like, say, this row right here, this third row, these 5 holes all are one circuit. Okay, so if I plug in this wire and this wire anywhere in those 5 holes, they're going to make a circuit. They're going to make a connection to themselves. In the picture here, the bent leg, right, they have a plus on it as well, but the bent leg is going to be the long leg, and that's a normal process or normal video or graphic for these types of things. So I'm going to take my long leg and my short leg here. So I'm putting these over here in 1 and 2 like it asked me to. So basically just kind of put the pin in the hole, and you got to kind of wiggle it. You want to wiggle it around a little bit to get it to sit all the way down. Okay, so that's sitting all the way down. I'm going to bend it so you can kind of see what's going on there. Okay, I'm in 1 and 2 there. The next thing I'll do is I'm going to put this resistor together. So they originally said E2 and G or F2. I'm going to go G2 and D, right? Because I've bent they're a little bit wider. You can see that as well, right? So I'm going to bend that down so you can see. Right? But what you can also see is that I'm in, like, this wire and this wire are in the same row, right? So this wire is in the same row as well, but you remember, if there's a break here, like this break here, there's no circuitry that's happening between this side and this side. Okay, so this is actually on 2 different sides of the breadboard, and they're not connected to each other except through the actual resistor itself. Okay, all right. So the next one then, I'll also notice that I'm doing this without the breadboard or the breadboard plugged in, right? So nothing's plugged in at this point. I'm doing all these wirings without any kind of power. You can do it a lot of times with power on, but when you start playing with the 5 volts and you play with active components, then you may actually break the component. So it's better to do everything without power and then plug it in afterwards. All right, so now I'm going to make this first connection, this one here. Right, so I need to be in the same row as the short leg. Right, so on the right hand side here, I'm going to be on the same row as the short leg. So here's my short leg right there, and I'm going to be on the same row. So I'm just going to come over here to E and plug in there. And then the other side of that wire, right, they have it brought over here to the ground. Okay, and I think what you'll notice also on the board here, there's 1, 2 grounds there, and there's also a ground kind of right over here. Looks like it's the 4th, 1, 2, 3, 4. So this would be ground here. Right? Any of those grounds would work. for today's exercise, we're going to put it exactly where they have it, which is on the third pin. So the third hole there, I'm going to put that wire in. Okay. So now I've completed the black wire on my circuit, right, by plugging it into the first row and into the ground receptor over here. Okay. The next one is going to be from pin 13 on the digital side to the row that has the resistor. Okay. Okay, so pin 13 over here, there's pin 13, and I'm going to bring this cable over here, I'm going to go on this other side here, and I'm going to plug it into the resistor, the same row as the resistor. So this is in the same row as that wire right there. Okay. All right, and that's the circuit. We've put the circuit together, right? So if this is wired properly, and I'm pretty confident that it is, we will be able to actually run this program here shortly. All right. So what I'm going to do now is I'm going to take I have a cable already ready, right? That's connected to my computer. So I'm going to plug that in, right? So and I'm going to hold down the Arduino with the plastic here so that I'm not messing up any circuits or contacting any circuits at all. Okay. And so it's booting up. And it looks like there's a blink program already running, so I need to kill that. So I'm going to do that by, here's how I'm going to kill that. So if I go here to, remember we also have to make sure we're on the right COM port. Okay, so let's tools and port, and on mine this is going to be COM port 15. That's this particular red board, and then I'm going to go to examples, and I'm going to go to basics, and I'm going to go to bare minimum, which is just going to bring up a blank program. Okay, and I'm going to send a blank program, so that this little arrow here is how I upload. If you're writing your own code, you may want to click the verify first to see if there's any problems with your code, and it'll kick out errors down here in this little space. Since this is a blank code, I know it's going to be functioning just fine, so we're going to go ahead and upload that. So right now it's compiling the sketch, so it's putting this into code that this board can handle, and then right there you saw the transmission lights. Okay, and then nothing's happening, right? That's exactly what I told it to do nothing. Okay, so this is where it should be if you got your your brand new board. Your blink program should. I was playing with it earlier, so the blink is was still left on. All right, and then with each of these exercises, you have this space here where you can copy the code, right? So here's the code they want us to run. So we're just going to hit copy, and I can actually go to the bare minimum here. I'm going to highlight all of this and delete. So just hit a delete button, and I'm going to right mouse click and paste. So I basically pasted this this code into this IDE over here. Okay. And right down here, this sketch is written by SparkFun, turns the LED on and off, right, repeats forever. And if we look at the code, right, so here's our setup loop, right? So our void setup loop is going to set pin mode 13. So pin 13 is going to be set to an output. Okay. And then in our loop, this is the loop that runs. So this setup is going to run once at the beginning of the program to set the variables, and then the second loop, this loop here, is going to continually run. So it's going to go line by line by line by line, and when it hits this little marker, it's going to come back up to the top where this marker is and start again. Okay, so then we've set pin mode 13 as output, right? So we're telling it output is on pin 13, and the first code that we're going to send to the program is to digital write pin 13 to high. Okay, and they've given us comments here, so that's going to turn on the LED. Okay, so high and low in Arduino world is on and off. Okay, and then we're going to delay for 2000 milliseconds, right? So, or 2 seconds, and then we're going to turn the LED off by digital writing it to low, and then we're going to wait for 2 seconds, and then we're going to come back up and write it to high. Okay, so this is a 2 second blink on and off, and if you read down here, that's what it's going to tell you, right? We're looking for a flash on for 2 seconds, off for 2 seconds, and then repeat itself. Okay, so since we're pretty comfortable that this code is going to be good, we're going to go ahead and just upload it to the board. again, watch my mouse here. Right here, these two lines, you can see where they start flashing. That's the code coming down. And now you see this is pin 13 that's on the board, and this is pin 13 that's off the board. So I've got the light turning on and off. Okay, fair enough. All right, if I wanted to make a change to this, like 2 seconds is a really long time to wait, and maybe that's fine for whatever, you know, there's all kinds of reasons why we would do that. Let's change this to, let's say, 500 milliseconds, and let's change the off to, say, 200 milliseconds. Okay, so those are going to be significantly faster, right? So we should get a much quicker blink out of this. So then if I just then send the upload again, you'll see over here that the program will stop, we'll upload a new program, and now you can see it's a whole lot quicker, right? So I encourage you to kind of play with these things. Once you start to figure out which one each one of these lines does, you can kind of goof around with that and play with it. All right, that's the basic circuit that you are expected to do. Okay, and they talk about the onboard LED, and then what's really cool about this, right? Again, just going through this and understanding these things, right? Please spend time. So as they go through these circuits, they will point out new things. They're not going to continually tell you about the void setup, right? They're going to tell you about new stuff that you're running into, and then kind of what it does, right? So then you can start to get a sense of how this works. Okay, and then down here in the very end, there are 2 challenges, right? The coding challenges. So if you want to earn some bonus points, right, you would turn in, instead of turning in your basic circuit, you would turn in one of the 2 challenges. Okay, and it's worth 10% more to turn in challenges for each of your assignments. So the very first one, computer screens, movies, and the lights in the house all flicker so quickly that they appear to be on all the time, but are actually blinking faster than the human eye can detect. So see how much you can decrease the delay in your program light before the light appears to be on all the time, but is still blinking. All right, so that one seems like pretty fun to try. So let's do this. Let's we already can tell, like you can see the 200 off. So let's go down to 100 off, or 100 on and 100 off. All right, so we're down to 1/10 of a second. Okay, and if I send that, we got the transmission here. So I can still see it blinking, right? So let's cut that in half. Right? And this is the idea, like if you've read what the lines of code do, then you can actually, you know, there should be, maybe with a little stretch, you can easily get to managing the code challenges. So we're going to drop this down to 50 milliseconds, right? So I can still see that, right? So let's drop it down. I'm going to go ahead and drop down to 10. To see if we can see it with 10 milliseconds, which, if my math is right, that's 1,000th of a second. No, it's 100th of a second. No, I'm trying to figure out what that is. Let's not worry about that. Let's keep on trucking. So we're gonna get down to 0.1 seconds. Oh, right. I can see it. Right, you can see it there. It looks like it's always on, but it's still blinking, right? So the light appears to be on all the time, but it's still blinking. So this looks, I can still see it's blinking. Let's try to go down to 5 milliseconds. All right, we're getting into ridiculously low amounts of time here. Let's see what that looks like. Okay, so a transmission going. All right, so that's pretty low. I don't know, the lowest we can go here is 1, right? I guess we can go to 0.0s, but let's just go down to 1. See what it looks like. Again, the idea of this, and I'm showing you how to do this one, right? So please, right, do ones that I haven't really shown you, first of all. But you can see the process here, right? So there, look, that looks like it's on all the time, right? So that one looks like it's on, so somewhere between 1 and 5, okay? So 1, right? Let's go to 2. Right? Let's see at what point does it start to blink again, right? So 2, 1, we know it doesn't look like it's blinking. Okay, I'm looking at this going, I don't see the blink either, right? So 2, that's a valid number as well. So let's go to 3, transmitting. Can you see that little flicker right there? I'm not sure if you can see it on your screen. I can see a flicker. Okay, so at that point 3 is too high, right? So as far as I'm concerned, as far as this particular challenge is concerned, right, I would have to be at 2 milliseconds in order to not see the flicker but know that there's a flicker. All right, and then at that point I've completed that challenge. So this is and if you're going to complete the challenge, I need to know that you're going to complete the challenge, because if I look at this, I'm going to say, you know, and you're going to have to tell me like what milliseconds you use, that kind of thing. Does that make sense? Because in this one, think about what I've asked you to turn in. I'm looking for a blinking light, and if you turn in a light that's not blinking on the video, then I'll look at that and go, well, it's not blinking, and you don't get any credit, which you should have gotten extra credit, right? So if in that case, you're going to want to, you know, stipulate in your submission that you we're doing the persistent vision, and here, you know, and you can actually, you know, screenshot this code and send the code so I know what's going on. Okay, something like that. So at this point, if you haven't already done the persistence of vision, I mean, I just did it for you, so let's not do that one. So you can do the Morse code, and the idea of Morse code is if you can get your name to blink in Morse code. Okay, and we can walk through that at a different time. But that's the blinking light LED, and then the different things about going on with, you know, inside of the actual assignments. If you run into problems, right, the first thing that you're going to do is you're going to look through these troubleshooting methods that they have down on the bottom and see if you can solve this issue. Okay, right? I know, because I know we had several people that had this issue here, and they didn't read this piece. Because they asked, you know, what was going on. So a lot of times, I mean, there's a lot of the stuff that going to answer your questions are going to be in these troubleshooting sections. Okay, if you have any questions at all, let me know. Otherwise, I hope this was helpful. I hope, you know, me going through this with you and kind of walking through this and showing you how it works is of benefit. All right. Other than that, have a good day, a good evening, good night, whatever time you're watching this. Enjoy, and I'll see you in the next video.